In this segment, we are going to solve a few questions based on similarity of triangles. Before we start with any question, I would just like to quickly summarize what we have learned about similarity of triangles. So we have learned that the tests for similarity are SSS, SAS and AA tests. If two triangles are similar, then their corresponding angles are also equal. If two triangles are similar, then their corresponding sides are in proportion. So if triangle ABC is similar to triangle PQR, then the ratio of AB by AB to PQ, the ratio of BC to QR and the ratio of AC to PR are equal to each other. Also, the ratio of the sides of two similar triangles is called the scaling factor. And let's use K as the letter to describe it. So K is the scaling factor. And so the ratio of the corresponding altitudes is also equal to the scaling factor. The ratio of the corresponding medians is also equal to the scaling factor. The ratio of the angle bisectors, the corresponding angle bisectors is also equal to the scaling factor. The ratio of the perimeters is also equal to the scaling factor. However, the ratio of the areas of two similar triangles is equal to the square of the scaling factor. So, these were the different ideas that we have learnt in similarity, and now we are going to solve a few problems where we are going to require these concepts. So, let me just freeze this for a minute and then we will start with our questions. So let's start with our questions now. The corresponding altitudes of two similar triangles are 5 cm and 7 cm. Find the ratio of their areas. So here it's given that the corresponding altitudes of two similar triangles are 5 cm and 7 cm. So I can say that the ratio of the sides of the triangle, the ratio of the corresponding sides is equal to the ratio of the corresponding altitudes, which means that the ratio of the corresponding sides is equal to 5 cm upon 7 cm, which is basically equal to 5:7. And now we wish to find the areas of the triangle, ratio of the areas. So I know that the ratio of the areas of the two similar triangles would be square is equal to the square of ratio of their corresponding sides. Square of the ratio of their corresponding sides. So what is the ratio of their corresponding sides? The ratio of their corresponding sides is 5:7. So I will take the square of 5:7. So it becomes 25:49, right? And therefore the ratios of their areas, the ratio of their areas is equal to is 25:49. So here the concept used was the ratio of the sides equals the ratio of the corresponding altitudes, and ratio of their areas is square of the ratio of their corresponding sides. So using these two concepts, we were able to solve this particular question. Let's continue with the next one now. The areas of two similar triangles are 25 square centimeter and 36 square centimeter. If one side of the first triangle is 3 centimeter long, find the corresponding side of the second triangle. So in this particular question, let's list down what is given. It is given that the triangle 1 is similar to triangle 2. The area of the first triangle, that is area of triangle 1, is 25 square centimeter, and area of triangle 2 is 36 square centimeters. Okay, and one side of the first triangle, so let's assume it is side 1, is 3 centimeters, and we have to find the corresponding side of the second triangle. So let's assume that corresponding side is S2. So what is the relation between the areas of two similar triangles and their sides? We know that the ratio of the area, so area of triangle 1 divided by area of triangle 2, the ratio of the area is square of the scaling factor. So the scaling factor is basically the ratio of the sides, that's S1 by S2. And let us find the area of the two triangles. So the area is given as 25 and 36. So 25 by 36 is going to be equal to S1 by S2 the whole square. And now we should of course write the justification. The justification would be the area proposition of similar triangles. That is one way of writing the justification. Or you could also write the complete statement. Ratio of areas of two similar triangles is the square of the ratio of their sides, right? Ratio of their sides. And this is a much preferred statement because it clearly explains what you are using. And now I need to find side 2. Side 1 is given to me. So let me substitute the value of side 1 now. So I get 25 upon 36 is equal to side 1 is 3. So 3 upon side 2 the whole square. Now I can take square root on both sides. So square root of 25 by 36 is therefore equal to 3 upon S2. And square root of 25 upon 36 is 5 by 6. So 5 by 6 is equal to 3 upon S2. Cross multiplying 5 S2 is equal to 3 into 6, which means S2 is equal to 3 into 6 divided by 5. And therefore the corresponding side of the second triangle is 18 upon 5, which is 3.6 centimeters. Okay. So this is how we can find the corresponding side of the second triangle. The only idea used here was the ratio of the areas is equal to the square of the ratio of the corresponding sides. This property is true when you have two similar triangles, and that was precisely used in this particular solution. So let me pause for a couple of seconds and then we will continue. Okay, next problem. The perimeter of two similar triangles ABC and PQR are 36 centimeter and 24 centimeter respectively. If the length of PQ is 10, find the length of AB. So let us list down what all is given in this question. It is given that the perimeter of triangle ABC is 36 centimeters and perimeter of triangle PQR is given as 24 centimeters. The length of PQ is given. So PQ is given as 10 centimeters while the length of AB is what is asked. So now we have to find the relation between the ratio of the perimeters and the ratio of the sides. We know that triangle ABC is similar to triangle PQR. So this is actually another thing that was given in the question. And therefore I can say that because these triangles are similar, the perimeter of triangle ABC divided by the perimeter of triangle PQR, the ratio of the perimeters will be equal to the ratio of their sides, which is AB divided by PQ, right? We know that the ratio of the perimeters is also equal to the scaling factor, which in turn means that the ratio of the perimeters is equal to the ratio of the sides. This is because ratio of the perimeters of two similar triangles equals the ratio of the sides. Okay, so now let us substitute all that we know. We know that the perimeter of triangle ABC is 36. So 36 divided by perimeter of PQR is 24. So 36 by 24 is equal to AB divided by PQ is 10. So this would imply AB is equal to 36 multiplied by 10 is 360 divided by 24, which is equal to 15 centimeters. Therefore, the length of AB here is 15 centimeters. You will notice that the perimeter is 1.5 times. So 24 into 1.5 is 36, which is why AB is also 1.5 times PQ, and that's why 10 into 1.5 is 15. Another thing that you should notice here is when I took the ratio of the sides, I took the ratio of the corresponding sides. So AB and PQ were the corresponding sides, which is why I took that ratio. So let me again pause for a few seconds and then I will move on to the next question. Triangles ABC and DEF are similar triangles with AB equal to 1.2 and DE equal to 1.4 centimeters. Find the ratio of the areas of these two triangles. So again, let us list down all that is given. I know that in this particular question, it's given that triangle ABC is similar to triangle DEF, right? This is given to me. Then it is also given that AB is equal to 1.2 centimeters and DE is equal to 1.4 centimeters. We have to find the ratio of their areas. That is, I have to find area of triangle ABC to the area of triangle DEF. So now let me see how to go about this question. Because I know that the triangles are similar, the ratio of the areas is going to be the square of the ratio of their sides. So what I can do is, I can say that as triangle ABC is similar to triangle DEF, the area of triangle ABC divided by area of triangle DEF is given by AB upon DE the whole square. And what is the reason? The reason is ratio of areas of two similar triangles is equal to the square of the scaling factor, right? Or equal to the square of the ratio of the corresponding sides. You could write that as well. So instead of scaling factor, you could also write it is equal to the square of the ratio of corresponding sides, because that is what scaling factor means. Equal to the square of the ratio of corresponding sides. So now that we have written this statement, let us now see what all is known. AB is known and D is also known, and this is what I have to find. So let me go ahead with the substitution. So area of triangle ABC divided by area of triangle DEF will be given by 1.2 divided by 1.4 the whole square. So I can multiply by 10 and I can multiply the numerator as well as denominator by 10, and so what I get is 12 divided by 14 the whole square. Actually, if you notice, I am multiplying it with 10 inside, so this is into 10 and into 10. Effectively, I am multiplying the numerator and denominator by 100 because that's going to be 10 square, but that's fine. As long as I do the same operation in the numerator and denominator, it should be okay. Now I can simplify both by 2. So this is 2 6s are and 2 7s are. And 6 square is 36 and 7 square is 49, which means the area of triangle ABC divided by area of triangle DEF is given by 36:49. This is the ratio of the areas of these triangles. So the concept used here again was the ratio of the areas is equal to the square of the ratio of these corresponding sides. So let me pause for a few seconds before I move on to the next one. Okay, let's move on. In two similar triangles ABC and DEF, the measurements of the sides are BC is 3 centimeters and EF is 4 centimeters, and area of the triangle ABC is 54 square centimeters. Determine the area of triangle DEF. So again, let us list down all things that are given to us. So it is given that triangle ABC is similar to triangle DEF, right? And BC is 3 centimeters, EF is 4 centimeters. The area of triangle ABC is 54 square centimeters. We have to determine the area of triangle DEF. So we have to find, to find area of triangle DEF. So let us start with our solution. I know that the triangles are similar to each other. So triangle ABC is similar to triangle DEF. This is given to us, which means the area of triangle ABC divided by area of triangle DEF is equal to, now here BC and EF are the corresponding sides. So BC upon EF the whole square, right? BC and EF are the corresponding sides, and the reason for this is ratio of the areas of two similar triangles equals the square of the ratio of the corresponding sides, right? And now let us substitute the right values. We have the area of ABC that's given to us, so it is 54 divided by area of triangle DEF is what I have to find. That equals BC. So BC is 3 upon EF is 4. So 3 upon 4 the whole square. So now I can go ahead and solve for the area of triangle DEF. What I get is 54 divided by area of triangle DEF is equal to 3 square is 9 and 4 square is 16. So now I can cross multiply. So 54 multiplied by 16 is equal to 9 times area of triangle DEF. So 54 into 16 divided by 9 is going to be equal to area of triangle DEF. And now if I calculate this, I get 96 square centimeters is equal to area of triangle DEF. So the area of triangle DEF is 96 square centimeters. Again over here the concept used was ratio of areas of two similar triangles being equal to the square of the ratio of their corresponding sides, which is basically the square of the scaling factor. So let me again pause for a couple of seconds. Okay, let's move on. It is given here that the perimeters of two similar triangles are 30 cm and 20 cm respectively. If one side of the smaller triangle is 12 cm, find the corresponding side of the second triangle or the larger triangle. So let's note down what all is given to us. It is given that the perimeters of two triangles. So let's note that down. The perimeter of triangle 1 is 30 centimeters, and the perimeter of triangle 2 is 20 centimeters. It is given that if one side of the smaller triangle is 12 centimeters, okay, so that means this particular triangle, which is the smaller triangle in these two, because the perimeter of the triangle 2 is lesser, this is the smaller triangle, right? So it is given that one side of this triangle, so S2 is 12 centimeters. We have to find the corresponding side of the larger triangle, right? So let's assume that the corresponding side is S1. This is the larger triangle. So now what I'm going to do is, I know that the ratio of the perimeter, so it's given that the two triangles are similar. Therefore, the ratio of the perimeters of the two triangles is going to be equal to the ratio of their corresponding sides. And this is because the two triangles are similar. So what I can do is, I can say the perimeter of triangle 1 divided by the perimeter of triangle 2 is equal to side 1 divided by side 2. Note that there is no square relation over here because the perimeters are involved. The areas are not involved here. Now perimeter of triangle 1 is 30 divided by perimeter of triangle 2 is 20 is equal to side 1, so that is not known, divided by side 2 is 12. So this implies S1 is equal to 30 into 12 divided by 20, which is equal to 18 centimeters. And therefore the corresponding side of the larger triangle is 18 centimeters. Now there is one flaw in this particular question. I am going to give you a couple of seconds. Please note if you can find out the flaw. The flaw in this question is the side is incorrectly mentioned because, see the smaller triangle, take the case of the smaller triangle. In the smaller triangle, it is given that the perimeter is 20, right? The perimeter is 20 centimeters and one side is 12 centimeters, which means the sum of the other two sides is going to be 20 minus 12, which is 8 centimeters. So sum of the two sides is lesser than the third side, which is not possible in case of a triangle. So these measurements actually are not mathematically correct, but as far as solving a question is concerned, this particular strategy should work fine. Yeah. So again, let me pause for a few seconds and then we will continue. So this particular problem basically violates the property of a triangle that sum of two sides has to be greater than the third side. That particular property is being violated in this particular problem. In two similar triangles ABC and PQR, the ratio of their corresponding altitudes is 4:9. Find the ratio of their areas. So we know that it is already given to us that the triangles are similar. So we know that triangle ABC is similar to triangle PQR, right? And therefore the ratio of their sides or the ratio of their corresponding altitudes is equal to the ratio of their corresponding sides, and this is a property in case of similar triangles, right? So the ratio of their corresponding altitudes is given, which is 4 by 9. So 4 by 9 should be equal to the ratio of their corresponding sides, which means that now I can find the ratio of their areas. So I know that the ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides, right? Which means the ratio of the corresponding sides is 4:9. Therefore, the ratio of the areas will be equal to square of 4:9, which is 16:81, and therefore the ratio of the areas will be 16:81. So here we use two properties. One was ratio of the corresponding altitudes is equal to the ratio of corresponding sides, and the ratio of areas was the square of the scaling factor. So these properties were used in this particular problem. So let's consider this question now. It's given that there are two triangles. If you notice, the angle given in both the triangles is 90 degrees. So let us shade it. So we have two right angle triangles given here. We have to prove that triangle POB is similar to QOA. So let's see what criteria can apply in these two triangles. I have one angle equal, right? I cannot apply the SSS test because the three sides of both the triangles are not given. Of course, I can use Pythagoras to find OP, but in triangle AOQ, I cannot find the other two sides. And SAS test is also not possible here because the two sides of triangle AQ is not known. But I can definitely think about the AA test because I have vertically opposite angles. So these two angles are equal in these two triangles. Let's shade them. And then I also have the 90 degree angle equal in both the triangles. So what I will say is, I would say consider triangle POB and triangle AOQ for similarity, right? And I know that angle AOQ is equal to angle POB because of vertically opposite angles. I also know that angle PBO is equal to angle QAO because both are equal to 90 degrees, and that's given to me in the question. And therefore I can say that triangle POB is similar to triangle. Now let's see. O corresponds to O because these two angles are equal. So O is the second letter. O should be the second letter. B is 90 degrees and so is A. So B corresponds to A. and therefore the third vertex has to be Q. This is by the AA test. So this is how you figure out the corresponding vertices of similar triangles. And the first part is therefore done. Now we have to find the length of AQ. Now because these two triangles are similar, I can say that PO divided by QO is equal to OB divided by OA, which is equal to PB divided by QA. This is because of corresponding sides of similar triangles, right? So let me write the full form here. Corresponding sides of similar triangles. And therefore, I can now think of substituting the known values. PO is not known and Q is also not asked. So let us just ignore this ratio. OB is given as 6 and OA is given as 10, which is equal to PB is given 9 and QA is what is being asked right now, right? So now I can definitely cross multiply. 6 times QA is equal to 9 times 10 is 90, which means QA is equal to 15 centimeters. So this is how you can find the length of QA after proving similarity. The test used here was AA test. So always finding out the equal angles is helpful. And then I simply use the concept of CSST. Let me pause for a couple of seconds before moving on to the next question. Okay, moving on to the next question. So in this particular question, triangle ABC and APQ is given. I have to prove that the two triangles are similar. That is the first thing that I have to prove. It's also given that BC is parallel to PQ. That's marked in the question. So how can I prove that these two triangles are similar to each other? Because I have two vertically opposite angles, let me mark them as equal. So these two are vertically opposite angles. And because the lines are parallel, I can say that I have a pair of alternate interior angles here. And as the lines are parallel, these alternate interior angles have to be equal. So let's mark them. Angle B and angle Q are equal, and angle A and angle A in both the triangles are equal, not because they share the same vertex or they share the same letter, but simply because they are vertically opposite angles, and that is why they are going to be equal, right? So these two angles are equal to each other. So I can use the AA test of similarity here. So let's write a proper proof for this. The proof structure for similarity is very similar to congruency. So I will start off with consider triangle ACB and triangle APQ, right? So I will have angle BAC is equal to angle QAP because of vertically opposite angles. And also angle ABC will be equal to angle AQP because of alternate interior angles, right? Alternate interior angles. And therefore, I can say that triangle ACB is similar to, now let us note the vertices. The vertex A in triangle ACB corresponds to the vertex A in triangle APQ. So A corresponds to A. B corresponds to Q. So B is the last letter and so is Q over here. And therefore P is the third letter. This is by the AA test of similarity, right? And that's why I can now say that, okay, so the first part is done. So now I need to find the lengths of AC and AQ. So because the triangles are similar, I know that AC upon AP is going to be equal to CB upon PQ, which is going to be equal to AB upon AQ. And this is because of corresponding sides of similar triangles. Let us now substitute the different values. AC is not known. I need to find that out. AP is 10.5. AP is 10.5 equals CB. CB is 8 and PQ is 12. And AB is not known, or AB is 6, actually it is known, and AQ is not known. So now what I can do is I can take the first two terms of this equal ratio to find AC, and then I can take the last two terms of this ratio to find AQ. So I'm going to do that now. So AC by 10.5 is equal to 8 upon 12. 8 upon 12 simplifies to 2 by 3. So AC is equal to 2 into 10.5 divided by 3, which is 21 by 3, which is 7 centimeters. Therefore, AC is 7 centimeters. And then let's find AQ now. 8 by 12 is equal to 6 by AQ. Cross multiplying, 8 AQ is equal to 6 into 12, which means AQ is equal to 6 into 12 divided by 8, which is 9 centimeters. And therefore, we found the length of the unknown sides. So here AA test was useful and the concept of CSST was very useful. Let me pause for a few seconds. Okay, let's move on. Okay, in this given figure, the measurements are shown as follows. Prove that the triangles ABC and ADE are similar to each other, and also find measures of angle A and angle C. So let's take a close look at this particular figure. You will notice that the 60-degree angles are equal to each other. So because these two angles are equal to each other, don't you think that DE and BC are parallel lines? Because the corresponding angles are equal, and corresponding angles are equal only when the lines are parallel. So I can say angle ABC is equal to angle ADE. Both are equal to 60 degree, that is given, right? And therefore, as the corresponding angles are equal, I can say that DE is parallel to BC, correct? So these two lines are parallel to each other, and so let's mark them as parallel. So now I can say consider DE parallel to BC. So because DE is parallel to BC, angle C is going to be 50 degrees because of corresponding angles, right? So angle C is 50 degree because of corresponding angles as the lines are parallel. So let's mark them quickly. So this is 50 degree and angle C is also going to be 50 degrees, right? And now I can say that I want to prove that these two triangles are similar. So I can say consider triangle ADE and triangle ABC for similarity, right? So if I consider these two triangles for similarity, I know that angle D is equal to angle B. I also know that angle E is equal to angle C, and therefore triangle ADE is similar to triangle ABC by the AA test. Because two angles of one triangle are equal to the two angles of another triangle, that is why these two triangles are similar to each other. By the way, in similarity, the concept of common angle is also very useful. For example, I could have also proved similarity as follows. I could have said, consider triangle ADE and triangle ABC for similarity. I know that angle D is equal to angle B, and in both the triangles, angle A is common, right? Angle A measures the same in both the triangles, and that is why by AA test of similarity, both these triangles are similar to each other. So I could have proved similarity even using this particular idea, or I could use the idea as shown on the right hand side. And now if I want to find angle A, then I can simply use the angle sum property. Using the angle sum property, angle A is going to be 70 degrees, right? So this is how I solved this particular problem. Concepts used where if corresponding angles are equal, lines are parallel. I use the angle sum property, and I use the AA test for proving similarity. Moving on to the next question. So the question says, in the following figure, prove that triangle AEB, let's shade it. So triangle AEB is similar to triangle DEC. Let us shade the two triangles. If you take a closer look at the figure, you will notice that these two lines are parallel to each other. So I can start off with consider the two triangles for similarity. So consider triangle DEC and triangle ABE for similarity. Let us now note down all that is equal. I know that angle AEB is equal to angle CED, and that's because vertically opposite angles are equal. So these are vertically opposite angles, right? And we also have parallel lines, and there's a transversal. BD is the transversal, which means angle EDC is equal to angle EBA, because these are alternate interior angles. And I know that the lines are parallel, so DC is parallel to AB. That is given to me. Therefore, by the AA test of similarity, I can say that triangle AEB. Now let us see the corresponding parts. A corresponds to C, right, because of alternate interior angles. E corresponds to E because those are the vertically opposite angles, and therefore D is the vertex which is left. And so the first part is proven. Now we have to find angle EAB. So if I want to find angle EAB, it's going to be quite simple. I should just use the properties of triangles, lines and angles and triangles. If this is 100 and this is 30, I know that according to the exterior angle property, this is 70. So if angle C is 70, then angle A is also going to be 70 degrees, alternate interior angles, and ABE is going to be 30 degrees, again because of alternate interior angles. So the concepts used here were AA test for similarity and also alternate interior angles. So in this segment, we have solved quite a few questions on similarity. This was the last one. And we will try to deal with more questions of similarity in the later segments. I will pause for a few seconds and then we end this particular session.